Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question I've chosen to go through here is from 2015 paper 2 and it's question 7. In the first part of this question we're given a lot of information. You'll notice that I've only taken a certain part of it. The first part of the question is to find OR, the radius of the smaller circle. And in order to do that, the only part of our diagram that we need is the quadrilateral AHKB. So you'll notice that I've drawn just this in and I'm ignoring the rest of the diagram for the moment. I know the radius of the big circle is 4OR, the radius of the small circle is OR. The distance between the centers of the circles is 20√73 centimeters, and the distance from H to K is 8OR. With this information, I'm going to be able to work out what OR is. So what we need to do in this case is we need to draw a line parallel to HK. So what I would do on my diagram, just draw a rough line that's parallel to HK. Okay? So I've drawn a line coming up here. It's parallel to HK, which means that this must be a right angle as well. So basically I'm forming kind of a rectangle here. But what I've also formed is I've formed a right angle triangle. And I know that the distance from here to B must be 8OR. So I know that this distance is 8OR as well. I know that the hypotenuse of this right angle triangle is 20√73. And bearing in mind that this is the distance OR, that means that since the distance from A to H was 4OR, that means that the distance from A to the corner of my right angle triangle must be 3OR. So rather than labeling this as 4OR, this bit is 3OR and this bit is OR. So now you'll notice that I have a right angle triangle and I've only got one unknown, which means I can sub into Pythagoras' theorem to work out the value of OR. So my Pythagoras' theorem is that a squared plus b squared is equal to c squared. And in this case, my c, or my hypotenuse, is the side opposite the right angle, which is 20√73. So I can say that 20√73 squared is equal to 3OR to be squared plus 8OR to be squared. So you'll notice I have one equation, one unknown, so I'm going to be able to find the value of my radius, so the value of my OR. So 3OR to be squared gives me 9OR squared. 8 by 8 is 64. OR by OR is OR squared. And 20√73 to be squared is 29,200. 9 and 64 is 73 OR squared. So I get 73 OR squared equals 29,200. So if I want to get OR squared on its own, I should just divide both sides by 73. If I divide both sides by 73 here, I'm going to get OR squared is equal to 400. If OR squared is 400, then clearly I need to get the square root of this. So my final answer to part A is that the radius, or OR, is 20 centimeters. So the radius of my small circle is 20 centimeters. And now I know the radius of my big circle is 80 centimeters because it's 4 times OR. I know what the distance from H to K is. So I've worked out a lot of values now. And we can use this value now to solve the rest of the question. Okay, so the second part of this question now, we're asked to find the area of the quadrilateral ABKH. Now, quadrilateral is just any random four-sided shape. Okay? So in this case, you should recognize that clearly my quadrilateral can be split into a rectangle and a triangle. It's relatively easy to get the area of a rectangle. It's just the length multiplied by the width. And it's relatively easy to get the area of a triangle, especially when it's a right angle triangle. The area of a right angle triangle is just half of the base by the perpendicular height. So in this case, my rectangle, the length of my rectangle was 8OR, but I now know that OR is 20 centimeters. So that means the distance from H to K, or the length of my rectangle, is 160. And I know the width of my rectangle is the radius of the small circle, which is 20. So to get the area of the rectangle, it's just 160 multiplied by 20. And then I want to also get the area of the triangle. So the area of the triangle is a half multiplied by the base multiplied by the perpendicular height. Now, the base in this case is going to be 60 because if the radius of the big circle was 4OR, I know the distance from here to my rectangle is 3OR. 3 times 20 is 60. So that means my base is 60 multiplied by my perpendicular height, which the perpendicular height in this case is 160. So the area of my triangle is just a half multiplied by 60 multiplied by 160. And if we plug all of that into our calculator, it works out as 3,200 plus 4,800. And if we add both of those together, it works out that the total area of the quadrilateral is 8,000 centimeters squared. So for any question where you're trying to get the area of a random shape, always just try and divide it up into shapes that you can actually recognize. So in the end, that was relatively straightforward, getting the area of a rectangle and the area of a triangle. Okay, so for part C of this question, we're asked to find the angle HAP. Now, what I've done is I'm still sticking with just my quadrilateral we were dealing with in part A and part B. Because I want you to notice that if you're dealing with the angle HAP, it's this angle here based on my diagram. But I don't actually need to worry about the whole thing. Because all I'm going to do, so this one leads on to P. And all I'm going to do in this case is work out what the area of what this angle is and then multiply it by 2. So while I'm doing this question, I'm actually going to ignore the bottom half of my diagram. Because I just want to work out the angle HAB and then multiply it by 2. Because clearly the graph is clearly our diagram here is symmetrical. So actually all that I'm concerned with is my right angle triangle here. And we can just go back to junior cert trigonometry to work out what this angle is. Now I know the opposite, I know the adjacent, and I know the hypotenuse. Which means I can use sine, cos, or tan in order to work this out. In this case, let's say that we decide to use sine. Okay, so the sine of angle HAB is the opposite over the hypotenuse. The opposite in this case is 160, and the hypotenuse in this case is 20 root 73. So in order to get the angle on its own, we bring the sine across. So the angle HAB is equal to sine inverse of 160 over 20 root 73. And again, the question said it's in degrees, so make sure you have your calculator in degrees when you're working this out. So if I get sine inverse of this, my angle works out as 69.44 degrees. So I know that the angle in here is 69.44 degrees. The question asked me to find the angle HAP, which is the one which is this whole distance if I continue A onto P, which clearly it's just twice as big as the angle HAB. So all I need to do in order to get my final answer is 69.44 multiplied by 2. If I multiply that by 2 to the nearest degree, it's 138.9 degrees. So my final answer in that case is 138.9 degrees. Okay, so for the final part of this question, we need to get the area of the entire shape. Now you should recognize that this shape can be divided into 4 distinct shapes. So the first thing we're going to do is we're going to discuss the area of the quadrilateral HAKB. So the quadrilateral at the top. We then also need to add on the area of the quadrilateral at the bottom, which is PABQ. Then we're going to try and get the area of the sector of the small circle that's not included by the quadrilateral. So this section here. So for the moment, let's just call that the sector KBQ. Then we're going to get the area of the sector of the big circle that's not included by the quadrilateral. So in this case, we're going to call that the sector HAP. So 4 separate sections. If I get the area of each of those and add them all together, that gives me the area of the entire machine part. Now you should recognize from part B that I've already worked out the area of HAKB. I know from part B that the area of the quadrilateral at the top is 8,000 centimeters squared. And now clearly this is a perfectly symmetrical shape. So if the area of the top quadrilateral is 8,000, then the area of the bottom quadrilateral is also 8,000. So I know 2 of my sections, so actually all we really need to do in this question is work out the area of the 2 sectors. In C part 1, I worked out that the angle at A is 138.9 degrees. I know that both of these angles added together have to add up to 360, which means that the angle to the left of A must be 221.1 degrees. Now you can, if you look in your log tables, to get the area of a sector, it's pi r squared by theta over 360. So I need to plug that in to get the area of the sector KBQ. And then I'm also going to plug that in to get the area of the sector HAP. So I'm going to sub into the same formula twice. I know the radius of the big circle is 80 and the radius of the small circle is 20. Now you should recognize that the angle here, 138.9 degrees, is corresponding with this angle. Okay, so the angle at A here is corresponding with the angle at B. So that means the angle in my small sector is 138.9 degrees, which means I know all the information that I can just plug straight in. So let's just continue on. 8,000 and 8,000 is clearly 16,000. That's the area of my two quadrilaterals. Now if I'm getting the area of my small sector, it's pi times the radius squared, which the radius of my small circle is 20. So it's pi times 20 squared plus the angle over 360. And I know the angle in this sector is 138.9. So it's 138.9 over 360. So that allows me to calculate the area of the small sector. Now I also need to get the area of the big sector. So the area of the big sector will be pi multiplied by the radius squared. The radius in this case being 80, so it's 80 squared. And then theta over 360 becomes 221.1 over 360. And now I can just plug all those values into my calculator. And if you do that, your final answer, the area of the entire machine part, works out as 28,833 centimeters squared. So my final answer in that case was this. So I think the key to all those questions where the diagram seems quite complicated is just break it down into shapes that you recognize. So all we did there was we broke it down to rectangles, triangles, and sectors. So again, I hope this video made sense. If there's anything you're unsure of there, then just let me know in class during the week or send me an email and I'll try and explain it differently.